Alright, here we are, a couple physics students. We have to videotape a physics problem and the solution to the physics problem for our class. Here we go. A model rocket of mass 0.25 kilograms is launched vertically with an engine that is ignited at timer equals 0, as shown above. The engine provides an impulse of 20 Newton seconds by firing for 2 seconds. Upon reaching the maximum height, the rocket deploys a parachute and then descends vertically to the ground. So basically, rocket goes up using its engine for 2 seconds, then continues upward without the engine, and then deploys a parachute after it reaches its maximum height. So, the first question asks us to draw a free body diagram for each part of the rocket's flight. The part where the engine works, the part where the engine shut off, and then the part where the parachute is deployed. So here's each dot represents the engine, or the rocket. As you can see, we're drawing a downward arrow. This represents the force due to gravity, which equals mass times the acceleration due to gravity. The upward arrow is the force due to the engine of the rocket. Alright, for the second segment of the flight, the only force acting upon the rocket is the force due to gravity, because at this point the engine has shut off. For the third dot, there are two forces again. One is the force due to gravity, the other is the force due to tension from the parachute cords attached to the rocket. Alright, that's the end of the first part. For the second part, we're asked to find the acceleration in the first 2 seconds of the rocket's flight while the engine is still on. So what we do is we're given the impulse, and we know that impulse is equal to force times the change in time. So we just solve for force. We know the time is 2 seconds, so we know that force equals 10 newtons. The seconds cancel out, and the units. We know that force equals ma, mass times acceleration, and we know the mass of the rocket is 0.25 kilograms. So all we need to find is acceleration. So we use algebra to solve for acceleration. And acceleration is equal to 40 meters per second squared. So that is the answer to the second question. Now for the third question, we need to find the maximum height that the rocket reaches. So what we have to do is we have to split it into two parts. We need to find the distance it goes while the engine is on, and then combine that with the distance that it goes when the engine is not on. And then that will be the answer. So what we do is we use the equation, the change in distance equals initial velocity times time plus 1/2 times the acceleration times t squared. So we know that the initial velocity equals 0. And the acceleration is 40. And we know that t equals 2 for the first segment. So we just solve using those numbers. So we know that the distance in the first part, in the first 2 seconds, is 80 meters. Now, we use the second part. We find the final velocity by putting v final equals v initial plus acceleration times time. V final equals 0 plus 40 times 2 seconds. The initial velocity is equal to 0 because the object starts at rest. So we find that the final velocity is equal to 80 meters per second. And we use that by putting it back into the equation after solving for time. And then putting it in for t in the previous equation used to find distance. And we find distance by putting 80 times 8 plus 1/2 times -10, which represents the acceleration due to gravity. And it's negative because it points downward, the opposite the direction of motion. And now we just solve for the distance. So what we get is 320 meters. And that is the answer to the second part of the equation. Or the third part of the equation. Sorry. And for the fourth part of the equation, we're asked to find the time that it takes to get to the maximum height. Now in the previous part of the equation, we found time by using v final equals v initial plus at. Now we know that the first part is equal to 2 seconds. So we can just add 2 seconds to the time we solve for. So the final velocity equals 0 because it's stopped at the top of its maximum height, while the initial velocity is equal to 80 because that's how fast it was going at the end of the at the beginning of the second segment. And then you add a -10 times t. And then you just use algebra to solve. And you get t equals 8 seconds. So we add 8 seconds to 2 seconds, and that is the amount of time that elapsed before going to the maximum height. And that's the end of our physics problem. This is Neil and Miguel's project for AP Physics, Mr. O'Neill's class. Have a nice day.